Good morning and welcome to this session, the first session on the general track on understanding API dispatching in NetworkX. Thank you for coming to PyData Global today, and I hope you enjoy all of these sessions. Without further ado, I'm going to hand over to our speaker, Aditi.
Can you see my screen? Can you all hear me, see me, see the slides, everything good? Okay, so I have the chat window open if you want to if you have any questions or anything. So here's a little bit about me. I'm Aditi Juneja, and mostly most of my usernames are Shafira Alvaricolo, and this is how I look online mostly, and I have mostly worked on API dispatching things and scientific Python projects, mostly NetworkX, and on the NX parallel backend, which is um, it has parallel graph algorithms, mostly written using joblib, and I'm also a NetworkX's core developer, and here are the slides on this link if you want to see them, and here's some of my previous stuff. So let's get started, and so let's start by what is NetworkX? So, NetworkX is a graph or network analysis Python library, and by graphs, I don't mean these kind of graph. I mean these kind of graphs, and you can probably see why why they are also called as network, because they kind of look like nets, and these circles are called nodes, and these lines between them are called edges. And these nodes and edges can be anything you want them to be. They can be people, or they can be web pages, or some sort of quantum state, and they are connected if one quantum state can go to the other, and they can be molecules or atoms, whatever you want them to be. And so you can put it in the chat, which node here do you think is the most important one? Okay. Yes. So a lot of people are saying 1, which is true, because one is the node that is connecting all of the other nodes. So it is important. But now if I make directed edges, or so you can think of it as there are 7 people, and the first person is following all of these people, but no one is following one. So here, who do you think is the most important node? Okay. Somebody said still 1. Okay, no. Okay. So all of the other nodes, because all of the nodes are important to 1, but none of the nodes think that 1 is worth following, which is sad. But if I reverse the edges, then then 1 is the most important again. So this importance thing, this can be like mathematically quantified into formulas, and you can call these like different things like between a centrality and all these things. But I think I have given the intuition of like what importance mean in a graph. And graph analysis is like not just about finding the important node, it is like how connected the graph is or how dense it is, and if there are like different um, possibilities of solutions, like different configurations of Rubik's cube. So you can also find like the shortest path between the unsolved state and the solved state. So there are like a lot of things that you can do with graphs. Um, Now let's move on to the NetworkX API. So like you import it and you create a graph object, and it is like a dictionary of dictionaries, and this graph object has different methods, and here I've just added like edges and nodes. So on the right you can see how this graph like looks in like a physical diagram, and here I am applying betweenness centrality to this graph, and betweenness centrality just like tells how important a node is. So here you can see that 2 has the highest betweenness centrality value. So you can say that, and like it also looks like 2 is important, because if I remove 2, uh, the graph will become like way more disconnected, uh, like compared to if I remove, let's say, 6. So but now if I try to do the same finding the most important node thing on a million node graph, and this zero point 0.5 is basically that the probability of having an edge between any two node is zero point 0.5. So you can think of it as like a really big and moderately dense graph, and in that graph if I'll try to find the most important node, it is going to take forever, because like NetworkX is written in pure Python, and that's kind of slow. So what should we do now? Uh, One solution is API dispatching, and now what is dispatching? So usually like the user makes a function call to the library and gets the output. So like you do an x dot betweenness centrality and you get the dictionary of betweenness centrality values. But in dispatching, you the user is making a function call, but there's the user is also providing some information about the backend. So then the main library can instead of implementing its own implementation of that function, it is going to call that function in the backend library, and then the backend library will give the output. And why would you do that? Because like backend library has a faster implementation, and this backend information does not like it can be inside the function call, or like as a global variable, or even in the graph object. So kind of this is like a very high level view of how dispatching is in NetworkX. So there are like, so here in the first one you can see that it's the normal function call, but there is like a additional backend keyword argument which has the backend name, and uh, so like this underscore dispatchable decorator is like on most of the functions in NetworkX, and it checks if there is some backend information, and accordingly it like redirects the implementation to the backend package. And you can also um, instead of like doing this backend is equal to parallel, you can send in a backend specific graph object which has an attribute which tells that NetworkX that um, this backend should be implemented. And you can also have like a priority queue. So you can have like over here I only put graph plus, but you can have like multiple backends here. And like if graph plus does not implement that algorithm, then it will go to the next backend in the list, and so on. And now you might think that how are we going to like call the backend library. So one way is to you import the backend library and then call the function, but that is like a very raw way. And like you would have to put a lot of information about the backend library into the main library to do that. So it needs to be a bit more sophisticated than just like calling the backend function. And also, like, why are we doing this? Why can't we just like have better implementation in the main library, which is like fast? So let's answer the why first. So NetworkX is a old project and it has like a lot of algorithms already. So we can't like have a few algorithms that are like good on multiple cores, written in multiple cores, and then a few algorithms that are well in like a language like Rust, and a few algorithms that are good on GPUs. So um, that is so we need to like have consistency, and also like it's easier to maintain if there is some consistency. And also the when we are using this dispatching approach, the user API remains same, but like if we have um, different implementation in the main library, then there might be a chance that even the user API is different. And it depends on your project, like if dispatching will be a good fit for NetworkX, it works. And there is a question in the chat that what do you mean by backends like C implementation that will not be natively used? It in the callback. Okay. Not be natively used unless you. Yes, so like backend is like the implementation won't be used unless the user has you know like if user is making a simple call, then it will just return it will just run the network access implementation. But if the call is kind of like this, then it will dispatch to a different backend implementation, and that can be a C backend also. So now let's come to like how is that happening, like main library calling the backend library. So there are three main steps to it. And so it's like first you find that backend library, based on the limited information that the user has given, and then you try to find that function in the backend, and then you just call it and return the output. And so in NetworkX, there's like one additional step, because like NetworkX has its own graph object, and for a backend to run a function, that graph object needs to be converted into a backend specific graph object. So um, there's that additional step in NetworkX's dispatching. And so to find the package, we use something called as Python entry points. So Python entry points are like Python entry points. They point to an object, and they belong to a group, and they have a name. So you can call, you can get all the packages in a group all at once, just by running a single command, like entry point group is equal to networkx.packages. So this makes like very easy to get all the backend packages, and then like the name is what we get from the user, and then we can like easily find the backend. And the conversion, like here you can see the object that is being referred to is a backend interface object, which is in this interface module, and interface module is in NX parallel module. And so this object has like two attributes, which are functions, which convert the NetworkX graph to the backend graph, and backend graph to the NetworkX graph. And this object also has like all the algorithms implemented in the backend as its attributes too. So we can just like fetch the load the um, the algorithm of this like object. Um, so this is like a summary of like what all goes into making a NetworkX backend. You need to have an entry point, and that entry point needs to refer to an object which has like these three things as attributes: one, like two functions for converting, and all the algorithms um, for like so that the main library can know that this is the implementation I need to implement. And also, because we have a graph object, so we also need to have a backend specific graph object, which this networkx underscore backend attribute, which contains the name of the backend. And there are a lot more things about dispatching, like you can automatically test your backend. You don't have to write any test, you can just use the test written in NetworkX. So this, like you can see the networkx underscore test underscore backend variable is set to the backend name, so it will automatically like run all the tests in NetworkX with a parallel backend graph object. And the second environment variable fallback to NX is just that if NX parallel does not have a, um, an algorithm implemented, it will fall back to the NetworkX's implementation. And you can also have like additional backend arguments. So here, like the get chunks is not uh, a keyword argument that NetworkX offers. It is something that NX Parallel gives, and you can just pass it like this, and it will get handled properly. And there are configurations like you can set configurations for each backend. And there is also a second entry point, which is like it's just a function which returns all the information about the backend, and we just run that function, and whatever string that we get, we just um, display that on the NetworkX's official website. So that's so like we provide testing facilities also, and like you can also like have documentation for your backend, and also there is very basic logging, and caching conversion is basically like sometimes like for NX graphs, the time it takes to convert a NetworkX graph into a NX graph is like a lot, so we do that caching also. And so like is dispatching like uh, um, just like make things faster? No, because like there is a backend NX ArangoDB, which is like a database backend. So like you can perform the CRUD operations on it. And there has also been some discussions about having a visualization backend. So maybe having like interactive uh, visualizations instead of like how NetworkX has like very basic static visualization things, and maybe there will be like more stuff that people do in the future. And so here are like some of the projects that are thinking of adding dispatching, this entry point based dispatching. So in scikit image, the difference is that instead of a graph object, there's a image object which is basically a numpy array. So uh, if a cupy array is passed, then the function call will be dispatched to the QSIM backend. And yeah, so it is still in work. It is still a work in progress. And in sklearn, I think one of the things is that they don't have functions. They have like models, and those are like classes. So uh, that is going to be like a bit tricky to implement. But there might be like some way to still like implement it, and I think Tim Head would be the best person to talk about that. And in NumPy, like NumPy is a bit ambitious, but uh, Sebastian Berg was like interested in that. Like there are a lot of array libraries, and it would be nice if there is only like you can use all of them, but with just one user interface. And I think one of the problems with that was that for like in the conversion of arrays, the some of the information might get lost, like when you are converting a dask array into a numpy array. So like the chunk information, yeah. And like I wanted to like if you have a project, then try like implementing this entry point based dispatching, and like please share like whatever challenges or limitations you think this has. And here are like some of the places you can discuss. And the spatch repository is like still in discussion, like if we want to like spatch is like scientific Python plus dispatching. And it's like, do we want to have examples of dispatch like entry point based dispatching implemented in different projects, or do we want to like have a template? or both. Yeah, that's it. Thank you. And there are some questions from the docs. An example. Okay, let's take the GPU based NumPy. We have to do the same thing. Like the GPU based NumPy is like CoPy. Like I don't know how CoPy is like. I don't think like you can put CoPy arrays. Like you can like CoPy arrays and cographs are different things. Okay. Could you talk about caching a bit more? What is the overhead of converting a graph to a given backend? What happens if operation is a mutation of the graph? Like caching is on by default for all the backends in NetworkX. And I don't know much about like cographs. Like why like caching was mostly added because like graph conversion was very expensive, and we also have like this thing like should run, like we would like you should not run a algorithm that is like very fast in NetworkX only. So that's why caching was important. And what happens when did you look into alternate like alternatives? What would be like I wasn't very involved in like the discussions of like when it was building. I have been only working on it for like 1 year, and yeah, so like entry point based dispatching was something that like worked, and I think people decided to go by that. Um, but it's definitely not like good for all projects or work for all projects. And if you know any alternatives, you can tell me. And there are like other questions you can ask me. Maybe I can like answer them in chat only later if because there are only 2 minutes.
I think that's it for questions. Thank you, Aditi, for that really interesting presentation. I enjoyed that a lot. Thank you so much. And thank you everyone for those interesting questions. Can we have a big hand for Aditi, please? So our next talk in the general track is Deep Learning in Energy Management from Francesco Conti at 2 p.m. So if you're interested in that, head back here for 2 p.m. Thank you again, everyone, for coming to PyData Global. Hope you have a great day, and see you in the next session. All the best.